Alright, so I want to do a little review of integration by use substitution because you will need to know this for later on. So suppose that we have the following integral, let's say, choosing a color here. Suppose that you have the following integral, x squared e to the x cubed plus 1 dx. So I want to find the definite integral of this expression here, and in respect to x. So if I notice here in front of the e, I have as a factor the derivative of x cubed plus 1 as far as the x is concerned. Alright, so what do I mean by that? Well, if I take the derivative of x cubed plus 1, I'm going to have a 3x squared. Well, I have the x squared here. I don't have the 3, but I can play and get that later on. So I can use integration by substitution. Now, I would not be able to use integration by substitution if I had, for example, only an x here, because the x would be to the first power, and when I take the derivative of this expression up here, x cubed plus 1, I get a second power for x. So I would not be able to use integration by substitution if I only had an x here. Again, not the x squared. If I had an x cubed here, I would still not be able to use integration by substitution, because when I take the derivative of x cubed plus 1, I end up with an x squared. Okay, 3x squared. So this is why I can use integration by substitution. So as far as x is concerned, I have the derivative of this expression here in front of the x. So what I'm going to do, having said that, I'm going to introduce u, and I'm going to say that u is going to be equal to x cubed plus 1. And now what I'm going to do is I am going to take the derivative. I'm going to take the derivative of u in respect to x. So I'm going to introduce then du dx, and this is going to be equal 3x squared. Okay, so I am going to now multiply both sides by dx. So this implies then that du is equal to 3x squared dx. And now what I'm going to do is, because I have here x squared dx, and I want to end up with something that looks like x squared dx, I'm going to divide both sides by 3. So I'm going to end up with this over here, right? So this implies then that du over 3 is equal to x squared dx. So now I am going to change this integral to, okay, so my integral now becomes, okay, so this integral is going to become now du over 3 e to the u, yes? And now I can actually do this integration very easily, because this becomes really 1 over 3 e to the u plus c. But now what I am going to do is I am going to introduce the substitution u is equal to x cubed plus 1, which is exactly what I substituted before. So this is now going to imply that this integral then is going to be equal, this integral here is going to be equal to, let me actually circle this over here. So this integral here, okay, is going to be equal to, let me write it over here, is going to be equal to 1 over 3 e to the x cubed plus 1, okay, plus c. And this is the way you do integration by substitution.